Okay, class, in this video, we're going to set up two DHCP servers. I have all my machines booted. I've updated my network map to include the two IP addresses, 172.16.0.4 and 172.16.0.5. Those are the next two available IP addresses. So 0.4 will be used for DHCP1 and 0.5 will be used for DHCP2. So I'm signed into DHCP1 now. I'm going to go to the Ethernet card. Here's my gateway. Now, I'm going to join this computer to the domain. The only two DNS servers that know about this domain is DCDNS1 and DCDNS2. You notice that these DNS servers will forward here. These two DNS servers will forward here. But no DNS server will ever forward to these two. So your DNS client has to point to these two DNS servers, because if you point these two machines as DNS clients to these two servers, they'll never send that request up here. So you need to make sure that these two DNS servers point to the two DCs or DNS servers that know about your domain. That's really important. So in this case, sorry about that. I have two cats fighting. Give me one more second. Okay, so I'm going to point to DNS1 and DNS2. And I missed that box again. It's okay, when I join to the domain, it'll change the profile. So the next thing I'm going to do is resync the time. If I go to my DC1, I can see the time is 12:34 and my real machine is 12:34. So if I go to DHCP1, I can see it's 9:32 because I didn't shut these machines down. I'm trying to resync them manually and it's not working. So I'm going to have to reboot these machines. While that's rebooting, I'm going to configure the IP addresses for DHCP2. This IP address is going to be 0.5. Again, I'm pointing to my two internal DNS servers. They're the only one that knows about our contoso.com Active Directory domain. And again, I'm going to join it to the domain, so I'm not real worried about that profile, the firewall profile. Because when I join it to the domain, it automatically uses the domain firewall profile. I'm going to go back to the DHCP1, and my time is still not synchronized. Because I'm not joined to the domain, I should be able to manually change it. So once I manually set my time, I'm just going to change it back to automatic. That's important because if the time is more than 2 minutes off, you won't be able to do the next step. So I'm going to go and change my computer name, but this time also join it to the domain. It's going to query DNS, find out who the domain controllers are, then join the domain. Now I'm going to supply an account that's allowed to create computer accounts in my domain. So it's going to be Contoso / not / administrator. Then our standard password. So I'm going to join DHCP to the domain, DHCP2. This one, the time synchronized automatically, so that's good. If your time is more than 5 minutes off, you won't be able to join it to the domain. It's going to assume that the packet was um, altered in route if it took more than 5 minutes. So domain controllers don't trust packets that are 5 minutes old. So now I'm going to change the computer name and join this to the domain as well. So now I'm going back to DHCP1. I'm going to sign in. Now that I'm part of the domain, I have two sets of user accounts I can use. I could use local user accounts or domain user accounts. And over time, you'll develop when to use which accounts. Right now, I need to do some changes that's going to affect the entire domain. So I need to sign in with the domain admin account, not my local admin account. This is my local admin account. So I'm going to click on Other User. See how it automatically tries to sign me into the domain? But look what happens when I type the administrator account. It goes back to the local account. So when you're using the administrator account, you have to supply the domain name, always. If I was just signing in as a normal domain user account, it would default to the domain. I'm going to do the same to DHCP2. I'm going to click on Other User. user standard password. Make sure I sign in as a domain admin. While we're waiting for that to sign in, guys, make sure you keep updating your um, network map. When you want to go and add this IP address, just highlight DHCP1, then press F2, and that'll put you in edit mode, so you can add these IPs. I went and modified the map from the last time I used it, and instead of having arrows pointing to all these interfaces, I just put the IP under the name. There's our subnet for our DMZ network. There's our subnet for our private network. Here's all the public IPs that I'm using. Here's the private IP for this subnet. Here's the private IP for this subnet. Okay, so I'm going to install the software for DHCP. Just like all the servers, IP, computer name, join it to the domain, install software. So I'm going to do the first one graphically. Add roles and features. Till I get to server roles, choose DHCP server, add the tools to manage it, restart if needed, then install. So now I'm going to DHCP2. This time I'm going to do it on PowerShell. Install -window. I'm just hitting the tab key. I'm waiting for it to figure out what it is. So there it auto completed. Name, I hit -N tab, DHCP, -I tab. I don't want include all subfeatures. I want hit tab again, include management tools. Then -R tab to restart if needed. While it's installing, I'm going to pause the video. I'm back at DHCP1. Okay, guys, what I did was while I was paused, I went and edited the diagram, and I clicked this name up here, and it will change it to the name that you want it to read. So I just changed it to working network diagram, then exported it again. Every time you make a change, you need to re-export it, otherwise you won't save your changes. Okay, DHCP is installed on both DHCP1 and DHCP2. So I'm going to go back to 1. So I want to complete the authorization. Click on that little box. It's going to create 2 groups, a DHCP administrators group. So if you add a user to that account, they don't have to be a domain admin. They can just be a normal user account. They'll be able to sign into this DHCP machine and configure the DHCP server. You don't want to give someone domain admin rights just to configure the DHCP server. So that's what this group is there for. It allows them to go in and make changes to the DHCP server. If I add a user to the DHCP users group, that user would be able to sign into the DHCP machine and look at the DHCP settings, but not make any changes. Don't confuse DHCP user with a computer that gets an IP account. Every computer will get an IP account, whether they're part of either of these groups. This one is to allow people to make changes to the DHCP server. This one is allows users to view the DHCP settings. And lastly, it's going to authorize the server if it's part of a domain. If I took a DHCP server into a corporation that I didn't control, I could pass out bad IPs and prevent anyone from getting on the network. So in an Active Directory environment, your DHCP server won't start passing out IPs until the domain admin authorizes it to do so. So if this DHCP server senses an Active Directory domain, it has to be authorized before it'll pass out IPs. Click Next. So to authorize a DHCP one for domain, you have to be signed in as a domain admin, not a local admin. That's why I said it was important that you do this as a domain admin. So you can see that if I open up a command prompt and say, who am I? You can see I'm signed in as the domain admin. And that's where it's getting that credential. Then click Commit. Then close. Close this. Now I'm going to do it to the DHCP 2. So because I installed on the command line, I'm going to exit out of this, and then I'm going to refresh my server manager so this flag lights up. So once you refresh, go to the flag, and there you'll have the link to complete the DHCP configuration. Again, create 2 domain users, authorize the server to pass out IP addresses. Okay, now I'm going back to DHCP 1. Okay, here's the purpose of DHCP. It passes out all the IP settings that your computer would need to get onto the internet. It could pass out your IP address, your subnet mask, your gateway, your DNS servers. It could also pass out information about a boot server and a file to boot from. So if your computer doesn't have a local hard disk, it will actually connect to the boot server, grab a file, load it in memory, and boot up to that. If you remember in the CTS2391C class where we set up WDS, it was using DHCP to pass out that boot information. So that's what a DHCP server does. It passes out all IP settings. DHCP hijacked another protocol, bootp. So originally, that's what a DHCP server did. It was a bootp server. Basically, whenever a computer tried to boot up, it would talk to the bootp server, which is now DHCP, get all the IP settings that it needed, the boot file, and to um, then boot up off the network. So if you're doing Wireshark searches and you try to look for all your DHCP and you did a search of DHCP, it's not going to show up. You need to do a search of bootp because that's really the protocol that we use. So I'm going to go to Tools. Did I actually authorize the server? Yeah, I did. Excuse me. I'm going to go to my C drive. Go to Windows. Go to System32. Go to Drivers. Go to ETC or Etsy. Then highlight services and open with Notepad. So this is the file of all port numbers and protocols for common services. Like HTTP uses port 80 TCP. Hold on one second. The predecessor for HTTP was called Gopher. And basically that really means go for a page. So they just kind of nicknamed it Gopher. So that used to use port 70 TCP. DNS uses 53 UDP when a client is talking to a server. If two servers are talking together for DNS, they use port 53 TCP. I keep having to synchronize the time. Those time servers use NTP, Network Time Protocol, port 123 UDP. But what we're talking about today is bootp, which is really DHCP server. The server is going to listen on port 67 UDP, and the client is going to listen on port 68 UDP. So those are the port numbers that we're going to be using for bootp. This is bootp server and bootp client. I'm not going to make changes to this file. So just to give you an idea of where to find those common port numbers. So now we're going to configure the DHCP server. So I'm going to expand my DHCP server. If I don't have green check marks here, you most likely didn't authorize it. In that case, it'll say authorized here. If you can authorize it, you most likely signed in as a local admin and not a domain admin. So we're going to set up the server to pass out IP addresses for an IPv4 network. So we're going to right-click IPv4 and say New Scope. Think of a scope as a subnet. So the first scope I'm going to configure, or first subnet, will be for my private network. And that is 172.16.0.0/16. I always like to put my subnet address in the description, so when I look at this list, I know what subnet is what. Click Next. The first usable IP in that subnet is 16.0.1, and the last IP in that subnet is 255.254. So we have a total of 65,534 addresses we can use, which is we have 16 network bits, so we have 16 host bits. 2 to the 16 minus 2 equals 65,534 addresses. So that's a lot of addresses for this subnet. Click Next. In our range, we're using all the IP addresses, even the ones we're statically configured. So the NAT router is using 0.1. DNS1 is using 0.2. DNS2 is using 0.3. This one is using 0.4. So we don't want to pass that IP address out. But we want the DHCP server to be aware that that IP exists. So what we're going to do is exclude the first 100 IPs to not pass out. Guys, when I'm typing this number, I'm typing 172. I'm hitting the dot key on the number pad. 16, the dot key. 0, the dot key. 1. Then I'm hitting tab. 172.16.0.100. So I'm going to prevent this DHCP server from passing out the first 100. I'm going to go back. But it will be aware of the 100 addresses, but it just won't pass them out. I'm not going to use all one. I'm currently not using all 100, but it gives me some room to grow. And this subnet delay could be like a poor man's failover. If this DHCP server goes down, my clients won't be able to get IP addresses, and then they won't be able to get on the network. So you always want to have a backup DHCP server. If I didn't want to do failover or split scope or something like that, the way you should, what I can do is do a cheap man's failover. I could set up 2 DHCP servers exactly the same and put a 10 millisecond or 100 millisecond delay on the second DHCP server. So, and I'm going to go over how DHCP works here in a little bit with a diagram, but when a client receives talks on one DHCP server, it's going to accept the address of the first DHCP server it talks to. It's going to accept that DHCP offer. The second one will get ignored. So the second one will just kind of sit there dormant, trying to pass out IP addresses. Clients won't ever accept them because the first one already responded. But if the first one goes down, the second one will still be passing out IP addresses. The clients will accept it, so the clients will be able to get on the network. So you make 2 DHCP servers exactly the same, delay one by 100 milliseconds. And at that point, it'll be like a backup. It won't be used because the clients will have already accepted an IP, the IP settings from the first machine. So the second one just will be passing out IPs. No one will accept them. Now, how long ago are we going to give a client an IP address? So basically, if you're in a wired network, you might want to pass it out for 8 days if you're a really stable network. But if you have a lot of laptops that are coming in and out of your network, you might want to drop this down to 4 hours. So we're going to give someone an IP address for a certain length of time. At the end of that time, they're going to have to contact us and get a new IP address. If they don't contact us, they're going to release their IP address and assign themselves an IP from their peeper range. I can't remember the acronym. Let me look on my real computer. I can figure this out. Automatic IP addressing. No, that's not it. I'll figure it out in a little bit when I have a client in front of me. 169.254 range. Oh, there it is. APIPA. It's in a peeper address. Automatic private IP address. And basically it'll be any IP in the 169.254 address with the /16 subnet mask. It won't be able to connect to any computers outside of the subnet, but will allow it to communicate with other computers in the same subnet. So that's what happens once the lease expires and the client was not able to talk to the DHCP server again. The other thing that I want to point out is it doesn't wait till the end to try to renew the address. It tries to renew it in half the time. It's called half-life. So if I give a client an IP address for 8 days, it's going to renew that IP address in 4 days. If the DHCP server is down, it'll try it in 2 more days. If it's still down, in 1 day. If it's still down, 12 hours, then 6 hours, then 3 hours, then an hour and a half, until the time expires. At that point, it'll release an address and give itself an APIPA address. It's called half-life. For our network, I'm going to leave it at 8 days. That's how long we're going to give out a lease. Not only do we want to pass out an IP address and a subnet mask, I also want to pass out the gateway, the DNS server, anything else that your network has. So I'm going to click Next. I'm going to do 172.16.0.1. That's my gateway for my network. So when I pass out an IP, I want to pass out the gateway as well. There's my domain name that I'm joined to, and there's my 2 DNS servers that I'm using. These are set on my network card. This is when I join the domain. So it pulled that information and automatically populated these boxes. So that's where it got this information from. It's going to assume that you're going to want the DHCP clients to be part of the same domain and use the same DNS servers as the DHCP server itself. If it's not the case, then you can change this, but by default, most of the time this is right. This Win server used to be an old form of name resolution that used NetBIOS. It's still in use today, NetBIOS, but we really don't use Wins. We kind of use DNS over Wins now, but here this is for backwards compatibility. Um, I don't know why it's still there, but it is. Yes, I'm going to start passing out IP addresses now. In the past, if we had to work on one subnet, we had to take down the whole DHCP server. Now we can activate individual subnets, so we can take one subnet offline and still leave the other subnets actually up and running. So I'm going to click Next, then Finish. Now if this comes up with a blue symbol, and it generally does, I'm just going to hit Refresh to get rid of it. So here's my scope. There's the IP of usable IP addresses. That's the range of usable IP addresses. This is the range of IP addresses we're not going to pass out because we're going to use those statically on our servers. When we pass out the IP address and the subnet mask, we also want to pass out our router and our DNS server information and our domain name. So now I'm going to do another scope just to show you how it works for the DMZ. So I'm going to highlight IPv4, create a new subnet. This one I'm going to call DMZ, put in the subnet address. The range of usable IPs is 172.17.0.1 through 172.17.255.254. I'm going to exclude passing out the first IP addresses because I'm going to use those for my servers. Don't forget to click Add. I'm going to give it the IP addresses for 8 days. I'm going to configure the additional options. My gateway for this subnet is 172.17.0.1. There's my DNS servers. Again, I pulled it from the network card. We don't have a Win server. And click Next and Finish. Again, hit Refresh. Now look at this. For my scope options, I have the same two DNS servers there, and I have the same two DNS servers there. Now my router is unique to every subnet, but the DNS servers are the same. I don't want to have to keep going through and maintaining the same settings for each scope. So what I can do is I can set those up as server options. So I'm going to right click here and configure options. Now when you configure server options, they're going to be good for every subnet. So we're going to say for 0.6, excuse me, 006, we're going to say 172.16.0.2 and 172.16.0.3. Then I'm going to go down to 015 and put on our domain name. So now we've configured these things as server options, not scope options. Scope options are unique to that subnet. Server options work for every subnet. So I'm going to go down to scope options and delete them from there. And do it for the other scope as well. So now when I go back to the scope options for the first one, it's going to show me my scope options and my server options. If it's a little like a spreadsheet, it's a scope option. If it's a spreadsheet in front of a little computer, that's a server option. So if I ever had to change my DNS servers, I only have to do it one time, and that would affect all my scopes. There is my DMZ scope. There is my private scope. So now our DHCP servers are set up. So I'm going to go to my IPAM. I'm going to use this as a DHCP client to test. I'm going to boot it up. I'm going to pause the video while it's booting. Okay, my IPAM server is booted, so I'm going to sign in. See, it automatically got an IP address. Now, in a production environment, your servers will not have dynamic IP addresses because if the DHCP server goes down, then all of your computers won't get IP addresses, including the servers. Servers should always have static IPs, but just to demonstrate this, I'm going to use a dynamic IP, and later we'll change it to a static IP. So I'm going to go into my network card. I can see that I automatically have an IP address. There's my subnet mask. I obtained it on Friday, May 22nd. I'm going to release it in 8 days, the 30th. There's my gateway. That's the DHCP server I got the request from. And these are my two DNS servers. So basically what the client did was it did a broadcast called a DHCP discovery. And it sent that out on the network. The DHCP server heard it and offered that computer an IP address. Now, if that computer likes it, it will take that IP request, send it back to the DHCP server and request it. If that IP address is still available, it will send an acknowledgement so the client can then start using those IP settings. Now, if the client is just going to renew an IP address, it's going to skip the discovery and offer phase because it already has an IP address. If you ever notice that your home computer always gets the same IP address every time you boot up, well, because what it's going to do is when you get an IP address, it's going to store it in the registry. And when you boot your computer back up, it'll take that information and go directly to the DHCP server and request that same IP address. So this is the process for getting a new IP address. But if you're just renewing an IP address, you skip the discovery and offer phase. You go directly to the request because you already have an IP address. You already know who the server is, so you don't need to discover. So you'll contact the DHCP server with a request. If that IP is available, the DHCP will acknowledge. So this is a new IP, and if it was just a renewal, at that point, you can just do the request and the acknowledgement. So I'm going to go back to the DHCP server. I'm going to go into address leases, and I can see I have an address lease. 5254 800,000 AC. So I'm going to go to the IPAM again. I shouldn't have closed this out. I can see that's my MAC address right there. So in certain scenarios, you might want one computer to always get the same IP no matter what happens. So what you can do is you can create something called a reservation. I'm going to print this MAC address up in Notepad. Okay, now your MAC address of your DHCP server is going to have your IPAM server might be different than mine. Most likely it's going to be. So what I'm going to do is go to reservation. I'm going to say new reservation. And I'm going to do test client, whatever you want to call it. And I want this always to have an IP address of 100.1. I'm going to take my MAC address and put it in there. Just testing. Say this was your workstation in your office and you're a tech for a company and you always want your office computer to get the same IP so when you're out in the field you know what that IP is. You can do a reservation. Don't do this for servers. Don't do reservations for servers because you'd be in the same boat. If the DHCP server's down, regardless of whether it has a reservation or not, the server won't get an IP. Servers always should have static IPs. So I'm going to click Add and Close. So right now, I have an IP address of 0.101 for that machine. I want it to always get this IP address. So I'm going to go to my IPAM, open up Command Prompt or PowerShell. I'm going to do ipconfig, release, then ipconfig, renew. Now look at the IP that I'm getting. It's the 100.1. So I've reserved this IP to only this machine. Every time my DHCP server will give me this IP. So if I go up to address leases and refresh, I can see that I'm using that reservation. Notice when I set up that reservation, I didn't put any colons or spaces in the MAC addresses. It's not needed. Just use the MAC address. If you don't know the MAC address and that machine that you're dealing with is on the other end of a building or something, just go to your current lease and you should be able to see the MAC address right there. So I have two scopes right here. One for this and one for my private network. Excuse me. One for my DMZ network and one for my private. Now, if we look at our network diagram, let me pull it up. Here's my IPAM. Why did it give me an IP from this range and not from this range? Because when you're looking at DHCP and this client sends out a discovery packet, it's a broadcast packet. So what happens is it's going to broadcast, and these machines will hear that broadcast. A router will segregate this private network into two broadcast domains, one for this subnet and one for this subnet. Any broadcast done in this network will never reach over here. Any broadcast in this network will never reach over here because this router is not going to forward broadcast traffic. So when this DHCP did a broadcast for a DHCP discovery and then sent it on the wire, this DHCP server heard it and it noted the IP that it heard it on. So this IP is 172.16.0.4. So when it gave out an IP, it gave out an IP for the same subnet that it's in. So I heard it on 172.16.0.4 interface. That is part of the 172.16.0.0/16 subnet. So I'm going to give it an IP from that subnet. So that's why I gave an IP from here and not from over here, because the interface the DHCP server heard that request on. So now what do we need to do over here to get this client, a client over here to get an IP address? So we need to configure something called a DHCP relay agent. So I'm going to go to my NAT router. If we were in the Cisco environment, this would be called IP helper. So I'm going to sign into our domain, sign into our NAT router. This relay agent could be on any computer in this network. I'm just going to put it on this router because I already have it set up. What I need to do is listen for broadcast requests on this subnet, then convert it to unicast traffic and send it to the DHCP server. So I'm signed into my NAT router. I'm going to go to routing and remote access. I'm going to highlight general under IPv4 and install a new routing protocol. I'm going to choose a DHCP relay agent. Then I'm going to highlight it. Now this machine has three network interfaces, one attached to public, one attached to private, one attached to DMZ. Which interface do I want to hear broadcast request? I want to listen on the DMZ interface for broadcast request. So I'm going to add a new interface and put in the DMZ. And we're going to allow that to be sent through 4 hops, through 4 routers. That's okay. Click OK. So once I hear that request on that subnet, I'm going to right click, go to properties. I want to send it to one of 2 servers, 172 0.4 or 0.5, which we don't have set up just yet. So if this relay agent hears a request on the DMZ subnet, convert it from a broadcast request to a unicast request and send it directly to the DHCP servers. Click OK. And not only will you forward that request, but you're going to tell them which interface you heard it on. So I'm going to tell, when I get a machine over here that wants an IP address, this DHCP relay agent will forward it to this server or this server, and it'll say, I heard that request on the 172.17.0.1 interface. At that point, the DHCP server will realize that that interface is in the 172.0.0 subnet and pass out an IP address from this subnet. I'm going to demonstrate that. So I'm going to go back to my NAT router. Everything is configured. I'm going to listen on the DMZ interface for a broadcast request. And if I hear it, I'm going to send it to one of these two servers. And I'm going to include the IP address of the interface I heard it on. So I'm going to use my web server as a test. I'm going to go to my web server. I'm going to go back to automatic. Look, when I went to automatic, you see how this other tab popped up? There's my automatic private IP addressing. Okay, you could, if you wanted to, say use automatic IP addressing. Use a DHCP, and if that fails, use a PIPA. Or you could say use this IP instead. So you don't have to use a PIPA. I forget where I heard this question from. Someone was asking, I don't know whether it was a test question or a student did this in the interview. They were asking, how do you turn off IP addressing? Two ways. You give it a static IP, or you let it use DHCP, but then go into this alternate configuration tab and give it a static IP if the DHCP fails. So right now we are going to go back to automatic. So while that's doing its thing, I'm going to go to NAT. Go to routing remote access. I'm going to highlight the DHCP. I can see I received 2 requests. I'm not sure why it's not working. I'm going to give it a minute. I'm just going to disable its interface and re-enable it. Click yes. I decided to give it a minute. So now I have an IP address. Click details. This time it gave me an IP address that's appropriate for this subnet because I'm in the 172.17.0.0 network. So I have an IP address of 172.17.0.101. There's my subnet mask. There's when I got it. Then there's when I'm going to release it. Here's my gateway. Here's my DHCP server that gave me that IP address and my 2 DNS servers. If I go to the DHCP server, and I go down to leases, I can see that I have an IP address for that machine. Again, without that relay agent, this DHCP server would have never heard that request from the web server because the web server is in a different physical subnet. So the relay agent that I configured on the NAT will hear the request, convert it from broadcast traffic to unicast traffic, send it directly to the DHCP server, and at that point, pass the IP back to the web server. So I'm going to go back to my web server and configure that properly again. This should have a static IP because it is a server. Okay, so the next thing I want to show you is we configured this second DHCP server with an IP address and joined it to the domain and stuff like that, and we installed DHCP, but right now it has no settings. Okay, see, it thinks it's not authorized. Did I not authorize it? I thought I authorized it. So I'm going to close this out. No, actually, I'm going to show you. That's a good. When I go here and it's red, that means the server's not authorized. If you right click, it'll say authorized right here. You need to make sure that you're signed in as a domain admin, and I am. Go to the drop down, authorize my server. It's not working. Okay, so I'm just going to do it manually. I'm not sure why it's not working. Maybe it was already done. And this is just glitchy. Guys, sometimes it's just glitchy. I can't help that. I'm going to restart this DHCP server without, excuse me, I'm going to restart my DHCP service without restarting the whole server. I'm going to right click the server, go to all tasks and say restart. That will just restart this service. Oh, it was authorized. It just needed to be restarted. Okay, so my server's installed, but it's really not, there's no data in it yet. So what I'm going to do is go to DHCP1. As long as I have two servers that are authorized, I'm going to right click here, manage authorized servers. As long as I have two servers that are authorized, this will not be grayed out. So I'm going to configure failover. I'm going to accept both scopes, and I want to choose my other machine, dhcp2.contoso.com. Or you can click here and add the server. All I did was just type in the name, click next. And basically, I'm going to do load balancing. I want each server to handle 50% of each scope. And what it's going to do is it's going to mess with exclusion range. For one server, it's going to exclude a certain range. On the other server, it'll exclude the other range. In a production environment, I would want two secret passwords, so only they exchange with each other. For right now, I'm just going to disable that. I'm not going to have a shared secret password. You don't want this to exchange with any other server other than the ones I want. So that's why you should use their enable message authentication. You have a shared secret password. So we're going to have each server handle 50% and we're going to do load balancing. I could do hot standby, meaning one server handles 100% and the other server does nothing until the first one goes down. But for right now, I'm just going to do load balancing. Each will handle 50% of the load. Then finish. So it went through and excuse me, let me go here. I'm going to hit refresh. Oh, I'm thinking it's split scope. I'm sorry. It's not going to play around with the exclusion range. But what it did was, I'm going to go over to DHCP 2, hit refresh, and I can see that I copied all the information over. So when one machine gets an IP address, the other machine passes out an IP address, the other machine will be aware of it automatically. There's other things we could do with split scopes and stuff like that. I'm not going to go into that in this class. I'll do it in the next class. But we could either do split scopes or we can do failover. In either case, it's whatever's right for your organization. I like failover because the two servers are constantly communicating with each other. If you do a split scope, at that point, only they only talk to each other when they split the scope. After that, they're all independent. Okay, so that's it for DHCP. There's some other things I could talk about. I could go through. I'm going to try to avoid just to not mess up these two subnets. But we have something called a super scope. So let's say we had a subnet configured 192 dot your normal 192 address 192.168.0.0, which is a class C address. It has 256 usable IPs. Let's say we hire more people and we need more addresses. Well, instead of redesigning my whole address scheme, what I can do is add a second subnet, 192.168.1.0. And if I do that, the DHCP server will only pass out IPs from the first scope because that's the interface it heard it on. It heard it on the 192.168.0.0 subnet, so it's only going to pass out IPs in that subnet. But if you enclose both those scopes in a super scope, you're going to be telling your DHCP server you can use an IP from either subnet for this physical LAN segment. That's what a super scope is. But I'm not going to have you configure that. Um, it's only used in networks when you're like transitioning from one network scheme to another or really small networks. So I'm just going to avoid that, having you do that lab. But other than that, everything is set up, and that's it for DHCP. Thank you.